Good afternoon, judges. I'm Praveen. I'm from the team Boolean Pundits, and I present to you ChipSafe.
I'm Anurag, a first-year ECE student. I am Jerry, a fourth-year CSE student.
I'm Satvik, and I'm a first-year CSE student.
Today, we tackle the Intel Group's problem statement.
So our solution is to develop computer vision to capture a 360-degree scan of a person to detect tears or contaminants before entering the fabrication plant, which can be very susceptible to these contaminants as well, like including hair strands. So there's also cameras placed throughout the workspaces to detect these on the go and warn the workers of any contaminants that can harm the chips. We also developed a new suit design for better wearability, more comfort, as well as more cost efficient. And we developed a novel method for putting the process of putting on the suit, as it can be very complex. So to detect these tears, we basically created a model, a classification model for detecting them. And as you can see on the right, when the black contaminant was placed on the white suit, the contaminant bar went all the way up. And this was trained on the TensorFlow Keras model, and it was trained with a data set of 2,000 images, and the accuracy came out to be 83.25%.
All right, so for the computer vision, we chose to use OpenCV to help us accomplish our vision part of this project. So basically, we need to first detect where the person in the scene was. And so then once we could find the employee, we wanted to scan every part of the employee and then take those images from the video, pass it into the model to determine whether or not there's a contaminant on that part of the work. So here's like a brief demonstration of us pulling up the video feed from our computer. And again, right now this is just running the video feed. If we were to step back in the frame, it would be able to detect me as a person, and then the algorithm would kick in from there.
So some of the design changes we made were changing the headpiece so that we would sort of adopt a ski mask design where it's tight on the top as hair is the main contaminant, and then it would flare out and get looser as you go down. On the right side is a 3D model of what we imagined. And then another design we decided to do was have fans on the bottom, as that's one of the main complaints is the suits get really hot. So we created a physical representation just as a proof of concept. It seemed to work decently well. So we created a 3D model also. There's also a filter in the back to make sure no particles get out into the workspace.
Especially with the downdrafts in the workstations, it can push down the pressure, which pushes down all the air down, which can create more ventilation and comfort. So we also created a bootstrap to hold up the boots, so then they don't keep slipping. These are just elastic bands connected to your pants. So the redesigned process for putting on a suit is first you put on a pair of gloves. You put these on by putting inserting your hands into an automatic glove dispenser. And then you put on your headpiece first, and then your boots, and attach the straps to your pants. And then on top of that goes your suit, and then you remove the gloves and then put 2 additional layers of gloves on top of your hands.
Future implementations, we had a little difficulty implementing outlining the human, so better human detection with the computer vision, which would just make it easier to scan the person and therefore get the results.